Alright, for this problem, like any other, it's important that you attempt the problem yourself before you watch the video. I think the important thing about this problem is drawing a really good diagram. So let's see if I can do that. So the ball takes off and it has an initial velocity that is 33 degrees above the horizontal, but we don't know what v0 is. Flies through the air, and reaches some maximum height, y max. Okay, let's see, what else do we want to know? We want to know the initial speed of the ball, and then we also want to know the magnitude and direction of the ball's velocity when it's at its maximum height. Okay, so we want to know what is the velocity here. Okay, I'm going to give you a minute now that I've drawn the diagram to actually work through the problem and see if you can find these two pieces of information. So you should pause the video now and attempt to work the problem yourself. Okay, so for this one, I'm going to split the initial velocity vector into an x component and a y component. Right. And I want to note in this problem that we're in free fall, and when you're in free fall, that means the acceleration is 9.8 meters per second squared, directed downward. So we're going to consider the part of the motion from the beginning of the motion to this point up here at maximum height. And for that part, I'm going to have to split this up into x and y since the acceleration is different in each dimension. So delta x, I've got to write down our 5 variables here for delta x and delta y. Now I'm going to establish a sign convention that to the right is positive and up is positive. So for delta x, I don't know what delta x is. I do know that the initial x velocity is v0 cosine 33. Right? Because the triangle over here, v0 x is the adjacent side, v0 is the hypotenuse. We know that cosine 33 is adjacent over hypotenuse. The x acceleration is 0 in free fall. The y acceleration is minus 9.8 meters per second squared, right? Because down is negative. And we're told that it takes 2.4 seconds for the ball to reach maximum height. So that's the travel time for both x and y. Now, there are a couple other things in these two tables that I can fill in. First, I can fill in that the final x velocity is also v0 cosine 33. Since the x acceleration is 0, the final velocity will equal the initial velocity. I can also write down that the initial y velocity is v0 sine 33, and the final y velocity is 0. Right? At maximum height, it stops moving in the y direction. So I already know the direction of the velocity at maximum height. It's just in the plus x direction. And I also know that the magnitude is just going to be v0 cosine 33 because the y component is 0. So that should be pretty easy. Alright, so let's see if we can find the initial speed of the ball. I don't have enough information to solve the x component because the x acceleration is 0. Right? I can't, if I try to write, delta x is equal to, v0 xt plus 1/2 at squared. Right? I've got two unknowns here. V0 and t are both unknown, so I can't solve that. So I can't really do anything with the x component. I can solve the y component, though. Let me try to find v0 y. So I know that vy is equal to v0 y plus at, and therefore, so if 0 is equal to v0 y plus AT, therefore V naught Y is 23.52. So in my initial velocity triangle, which looks like this, I know that this side is 23.52. Right? So I can use the sine function. I can say that sine of 33 degrees is equal to the opposite side over the hypotenuse. I don't know why I put a degree sign there. Therefore, V naught is equal to 23.52 over sine 33, which is 43 meters per second. So there's the initial speed. From that, I could get the initial x velocity if I needed it, final x velocity, I could get the x displacement, and so on, but they're not asking for that. They're only asking for the, in part B, the magnitude and direction of the ball's velocity when the ball is at its maximum height. Well, I know that Vx is equal to V naught x, or sorry, just V naught cosine 33. So 43 cosine 33 is 36.2 meters per second. And I know that Vy is equal to 0, therefore the final velocity is just 36 meters per second in the plus x direction. That's it.